Construct Next is an approach of transforming by digitalization our industry or our projects by creating specific intelligent building systems using existing and emerging technologies. A quick bit about myself. I'm Sunil Prabhaker, CEO at Bay Building Architecture and Engineering, operating out of my Bangalore office, doing projects all over the country. Currently engaged in setting up a skilling academy called Next Academy, focused on the built environment and drawing deeply from the reserves of emerging and existing technologies in the process. Since we must all get consumed by this digital wave, we have put our domain minds to work, aggregated digital expertise from stalwarts around us to create a strategy, design, and implementation plan for measurable digital transformation in our industry by creating intelligent building systems, or IBS for short. We are inspired by Bryden Wood's inventive creation of a factory in a box, which could be shipped as an assembly kit to anywhere in the world. And by creating a step by step assembly process for such a system, the firm reduced the on site team strength by 75% and the installation time by about 50%. So, now what is Industry 4.0 as far as AEC is concerned? Fact of the matter is, every company today has to think like a technology company, irrespective of the vertical it belongs to. We are no different. So, the companies in the AC vertical will also be consumed by this 4.0 wave, and an intelligent building system driven by the technology disruptions is in order. So, what is an intelligent building system, or IBS, and how do we use IBS to transform a particular industry of our choice or a live project? Digital can be either operational or strategic. Operational is when we make small changes in using digital technology to areas of rate analysis and quantity surveying or document management by having an ERP, etc. Or it can be digital, which is the intelligent building system, a product of strategic transformation initiative. And of course, with all things digital, even for IBS, data is king. For IBS to be created, we'll need to acquire, store, visualize, analyze, and process the data to create a rationale for engineering outputs that will be beneficial for the industry. With an IBS, we can help construction companies to save resources and increase productivity and improve project profitability and quality, reducing project duration and cost, lessening the complexity of project management, and enhancing site safety for promoting a sustainable development of the construction industry. To understand digital transformation and IBS, therefore, it's necessary for us to take a look at where we are at the value chain of the industry and how the digital transformation is going to completely disrupt each link of the value chain. Let's see. This slide shows a reasonably evolved value chain, which shows you each link from raw material to product manufacturing to design to construction, operations, maintenance, renovation, demolition, and back to raw materials. There are several stakeholders, actors as we call them. There are new actors or new stakeholders coming to the mix, and there are several types of innovation that are happening all around us in each of the industry verticals of the stakeholders. Now, when this happens, there is so much of data that are being developed. The intelligent building system is a result of compiling of all this data from all the stakeholders, processing it and using it, interoperability of the data that we are collecting to create the information and to process that data and to create a platform for mutual benefit, for everybody's benefit by collaboration. Let's see where we are headed. This illustration shows you where we are headed for in our quest for Construct Next. It's also an indication of the various technologies that are at play and how they can impact the various links in the value chain that we've seen earlier. There is prefabrication and modular construction, advanced building materials, 3D printing through additive manufacturing, autonomous construction, augmented and virtual reality, big data predictive analysis, wireless monitoring and connected equipment, cloud and real-time collaboration, 3D scanning and building information modeling, which will all contribute in no mean way to disrupt, create change in various aspects of the building industry, as you can see in the illustration. Every man, machine, resource, component, building system, equipment that you saw on the slide earlier is a thing as defined in the Internet of Things. So now that we have a brief introduction to what we are trying to achieve, let's create a conceptual framework for the IBS and design an implementation strategy for making it effective across companies and across verticals. Many of the big five consultants, such as the Boston Consulting Group, have embarked upon very ambitious strategic transformation initiatives using digital technology. We have drawn from companies such as McKinsey Global, Boston Consulting Group, etc. Used a very popular strategy implementation tool called as the balanced scorecard, and used the balanced scorecard to create our own version of a value chain transformation scorecard to determine how companies can, in a step-by-step manner, by identifying key objectives and converting those key objectives to measurable outcomes and performance drivers, how companies can create a measurement scorecard for implementing a digital transformation strategy across their companies. As we said before, each link in the value chain undergoes a rampant digital disruption. We just look at the raw materials only because we don't have too much time, so we'll skip the other links in the value chain. So let's look at the raw materials, the basic building blocks, and how does digital disruption cause transformation in the raw materials and product manufacturing link of the value chain. So how is the raw material link going to look like in the near future? So this is the raw material and product manufacturing component of the value chain, which is said to be disrupted due to Industry 4.0, digitalization, and the various kinds of innovations from the various stakeholders. Time is not very far when you and I will go to a supplier and ask for 10 footings and 20 beams and 10 girders and so on and so forth. Time is not very far. We have today prefabricated RCC components, bath pots, factories in a box, all created by these new actors who want to basically shorten the time of the construction in societal interest and increase the profitability and the productivity of the industry. We have also converting this prefabricated components currently to smart construction objects, or SCOs as we'll call them in the rest of the presentation. Pre-built pods and construction systems, we are converting them to intelligent building systems and use technologies like additive manufacturing or 3D printing to create holistic solutions within a matter of days as opposed to years or months. The designers have to keep pace as well. The cement and sand and aggregate have transformed to bathroom pods and engineering building systems, etc., etc. So they've got to innovate and engage in the transformation through DFAMs, design for assembly and manufacture, and design for additive manufacturing. Similarly, with digital revolution impacting all the other links in the value chain, the combined value chain of the industry would begin to look something like this. Now this is the value chain illustration where we are going to be pretty soon. Changes, disruptions, transformations across all the links: raw materials, product manufacturing, design, engineering, construction, operations, renovation, demolition, etc. through digital as well as non-digital disruptions. We have so far rationalized the need for adopting digital technologies to transform our industries, our companies, our projects. Let's now look at this process of creating an intelligent building system for prefabricated buildings in stages through the following slides. Let's look at the stakeholders and also look at how this presentation is going to be organized hereafter. First, a quick look at how the study is organized. First, we'll look at the technologies that are available to us. Then we create a conceptual framework of the intelligent building system. And then next we create an operating framework for the intelligent building system. And then thereafter an implementation framework. The implementation framework is across two different prongs. The first prong is a technology prong or a technical prong. The second one is a management prong, which enables you to outline the key objectives and draw the outcome and the performance driver measures to ensure that the companies take the transformation strategy seriously, and every department in the company, every person in the company is measured in terms of how they are performing with respect to contribution towards digital transformation. Here's a look at the stakeholders involved in a prefabrication setup, the tasks or the responsibilities that they discharge, and the main stages where they will be experiencing the impact of digital transformation through the execution of a particular project. So there are owners, authorities or regulators, designers, constructors, supervisors, engineers, component manufacturers and logistics carriers. So with so many stakeholders and so many possibilities of systems and subsystems, what are the digital technologies available that are to be employed? In a prefabrication facility, prefabricated components are manufactured, such as footings and columns and beams, etc. Components are then assembled into construction systems. This is the assembly level. The earlier one was the unit level. And then the constructed systems are integrated into the construction sites, and this is called as the integration level. There are three levels in a prefabrication facility. Let's take a quick look at the different technologies that are involved at the different assembly levels. The component level, we use IoT, RFID and GPS to track and position the raw materials and components in the construction. At the system level, where the components are assembled into systems, we use IoT and a BIM platform to trace the manufacturing process and optimize the manufacturing schedule, analyzing the quality problems and arresting them. And at the construction site level, we have a concept of smart construction site by employing technologies of internet, 3D scanning, BIM, virtual reality, augmented reality, IoT, etc. And through a BIM based field management model that keeps talking with the BIM platforms of the manufacturers and the contractor subsystems to create a digital twin which has the same properties of the construction site. And so here is a summary of the different technologies very quickly. We have taken a look at the different assembly levels. We have also seen what are the technologies that can be employed across these assembly levels to gather the data. These data have to be grouped into blocks based on the source that they come from. A project level information data center has to be established, which is called as a PIC. An IoT BIM based database is established called IBDB. Authority monitoring and traceability system has to be established called AMTS, and an information system for products has to be established called ISP. These are the four different systems wherefrom we collect data, process that data by enabling interoperability and network flow, etc., and analyze and process the data to create information for the creation of the products through the ISP. So apart from the four systems that we have talked about, the creation of the intelligent building system also takes into account the various subsystems of the manufacturers, the suppliers, designers, contractors, etc., etc. So the collection of data, the analysis and the processing thereafter becomes an integrated whole. Without the collection of data and without the exchange of information over a network between the different stakeholders which determine the different sources of data itself, the possibility of creating an intelligent building system model will not be possible. And likewise, the ISP is a system for the construction of digital engineering products of prefabricated buildings based on all the integrated data and information which are processed and analyzed. Some of the subsystems which are employed by the contractors and the designers, the logistics operators, etc., are shown here. For example, project quality traceability system, which we call as PQTS, or the construction site resource element management system called REMS, component production planning scheduling subsystem called CPPS, etc. A few more of those subsystems: material supply management, SCM, of the logistics operators and the manufacturers, component transportation and dispatch system CTDS, and the integrated design system of the designers IDS, which subsumes the building information modeling system. In summary, therefore, the various systems that are employed along with the subsystems of the contractors, designers, and the logistics operators, etc., would look like this. We have PIC, IBDB, AMTS, and ISP, and a suite of subsystems which run across the manufacturers, suppliers, designers, etc., compiling the big data that we need for the creation of the intelligent building solution. Now that we've seen all this, let's take a quick look at the conceptual framework of the IBS. Now here is how a conceptual framework of the IBS would look like. As you can see here, the various systems, AMTS, IBDB, ISP, PIC, etc., what we have seen earlier is depicted here, indicating very clearly the flow of data and information between the subsystems of the contractors, the authority regulators, and the owners. The various purposes why these systems are in place and the roles and responsibilities of each of the sets of stakeholders also loosely indicated here. The objectives of lean construction, maximizing benefits, supervising and control, safety and quality control, and quality traceability, etc., are very clearly indicated in this particular operating the conceptual framework of the IBS. The interaction between the project information center and the transmission of information back and forth across these different systems and subsystems through the networks of Wi-Fi, RFID, etc., and finally to benefit the construction site of resources, components, equipment, systems, men and things, etc., are also clearly indicated. So this gives you a basic or a conceptual framework from which to develop an operating framework, and we'll see the operating framework in the next slides. Let's take a look at what happens in the IBS operating framework. We create a design model subjected to analysis and clash detection, etc. Once found compliant, a set of data is then transmitted to different frameworks, sub-frameworks. So a construction-oriented design data is transmitted for on-site construction. On-site construction data integration happens through the network of RFID, IoT, sensors, etc. A set of manufacturing-oriented design data is sent to component production data integration. Component production happens in real-time, data is uploaded back into the system, and if it is qualified, it goes to the site for on-site construction data integration. The data is analyzed, quality cleared. If no design conflict is found, the IBS is created and the project is finished. If there is a change that is required in the design as per a design conflict, that will be indicated. The loop goes back into the design model and the entire system reroutes itself as has been indicated in this. A lot of technology related interpretations are possible for such a framework, and it may not be within the purview of a typical architect or a civil engineer unless you are very, very technologically orientated to delve deeper into this. And therefore we have used a system of aggregation of domain experts, which we bring in the architecture and the civil engineering part of it, and the needs of the owners, which we bring in, and then we aggregate the expertise from technology stalwarts, and then create a platform called Next Lab to create solutions for the specific needs of our industry. The final step is creating the implementation framework. We look at the implementation aspect in two prongs, as mentioned earlier, the technology prong as well as the management prong. We recommend a simple 10-step plan to implement the IBS. First, you build the smart construction objects or the SCOs. Then you establish a data acquisition system, which we have seen earlier, the PIC, AMTS, etc. Collect data from the SCOs through the data acquisition system, which we have seen in the first part of creating of the conceptual framework. Establish network integration system, which we've seen in the operating framework. Connect the smart construction objects through the network integration system, which we again seen in the operating framework. Establish information integration system. transmit collected data to the information integration system through the network integration system. We've seen the network diagrams through the operating framework. Establish data integration and analysis system, establish a visual integration system, and establish a multi-layered application integration system, which is the final output of the implementation. The other aspect of IBS implementation is the management aspect, for which we create a value chain transformation scorecard. We've identified 10 different platforms for creating such a scorecard. Within each platform, we have key objectives, we have outcome measures, we have performance drivers, and we indicate the different technologies that are to be used and the different systems that have to be created in overall integration of creating such a value chain transformation scorecard. So the different platforms are prefab and modular construction platform, advanced materials platform, design digitalization platform, building information modeling platform, autonomous construction platform, big data platform, wireless monitoring, cloud and real-time collaboration platform, 3D scanning and photogrammetry platform, and blockchain platform. The establishment of a value chain transformation scorecard has been made possible due to the interaction between the domain and the digital experts at Next Lab. So we've created the framework for intelligent building system, identified the different assembly levels, the technologies that are to be used, created an operating framework, designed a technology implementation method, a 10-step method for delivering the intelligent building system for a prefabricated building, and finally this management control or management measurement of such a platform, how effective it can be or it will be, and how a company succeeds in implementing the strategy of digital transformation is developed through or is measured through a value chain transformation scorecard. Some of the examples of the scorecard are shown here. We haven't shown you the measures, etc., which will be done based on specific requests. As you can see here, this is a template of value chain transformation scorecard for a prefab and modular construction platform. The objective for this particular platform is clearly defined, which is production optimization, quality control, supply chain optimization, etc. A brief description of what those objectives mean is also given in the other column, and there is a set of measures which are called as the outcome measures and performance drivers, which mention also the actual status versus what is achieved in current practice. The system of measurement which we have not shown here, the different measures and the actual status, etc., will be specifically applicable to the companies that are employing this particular scorecard. Okay, the systems to be developed are also shown very clearly here. This we have seen earlier in the operating framework and the conceptual framework as well, and the technology suites that are employed for ensuring that the scorecard sits in sync with the technology implementation framework of the IBS is also shown in this particular template. So this is a template for the prefab and modular construction platform, whereas this is a template for a design digitalization platform. Remember, design digitalization does not end here. We have a separate platform for building information modeling, because it is building information modeling and Internet of Things that combine together to create the digital twin that is at the forefront of creating digital transformation in our industry. Similarly, this is a template for an autonomous construction and digitalized construction management platform, and this one is for big data and predictive analysis platform. And as we speak, we are getting ready with the digital transformation template for a prefabricated factory building of 2 lakh square feet, which illustrates the 10-step IBS framework and a 10-platform IBS strategy. As I've shown you, if you have queries regarding digitally upgrading your company, your project, developing a new system which automates construction, you can contact me on sp@baydesign.in, and I've given you the telephone number. It was a pleasure presenting to you from all of us at Next Lab, which is a concept from Bay Building Architecture Engineering. Thank you very much.